Welcome to the channel. Today we will talk about fusion rockets that can have 10% of light speed. If you've ever dreamed of humanity colonizing Mars, you're probably familiar with SpaceX's Starship, the most powerful rocket ever built. Its promise is massive, delivering cargo and passengers to the Red Planet and beyond. But there's one problem we can't ignore: speed. As powerful as Starship is, it's slow, achingly slow by the standards of the cosmos. Let's put things into perspective. Back in 1492, it took Christopher Columbus about 36 days to cross the Atlantic Ocean from Spain to the Americas. A grueling journey, but one that changed history. Now, Starship, with its chemical propulsion system, is expected to take 6 months to reach Mars. That's over 180 days of drifting through the dark void of space. Why so long? Because chemical rockets, despite their insane thrust, are incredibly inefficient over vast distances. The issue is energy density. Chemical rockets rely on combustion, a chemical reaction that releases energy by breaking molecular bonds. If we want to cut down that 6-month journey to something far more reasonable, we need a new kind of propulsion. Enter fusion rockets. So, what's a fusion rocket and why does it have so much potential? Fusion rockets use nuclear fusion, the same process that powers our sun. Instead of burning chemical fuel, they fuse atomic nuclei together, releasing massive amounts of energy in the process. To put it into perspective, the fusion of just 1 gram of deuterium-tritium fuel releases as much energy as burning about 10 tons of chemical rocket fuel. And this isn't just theoretical. We've been achieving nuclear fusion in labs for decades. The trick is harnessing it efficiently. Fusion rockets would typically use a combination of deuterium and tritium as their primary fuel. These are isotopes of hydrogen. Deuterium is relatively easy to obtain from water, but tritium is rarer and usually bred from lithium. Another promising fuel is helium-3, an isotope that's incredibly rare on Earth but potentially abundant on the Moon. Using helium-3 would produce far less radiation than the more common deuterium-tritium mix, making it a safer option for long-term missions. But how fast could a fusion rocket actually go? Well, the answer is astonishing. With a well-designed fusion drive, we could potentially reach speeds up to 10% of the speed of light. That's over 18,600 miles per second, or about 67 million miles per hour. If we could achieve even a fraction of that, say 2% of the speed of light, the trip to Mars would take just 1 day instead of several months. Suddenly, the dream of human colonies on the Red Planet seems a lot more achievable. So, how does a fusion rocket actually work? First, you need to contain a plasma, a hot electrically charged state of matter where fusion can occur. This plasma needs to be heated to millions of degrees, far hotter than the core of the sun. To do this, powerful lasers are used to ignite the plasma, creating the conditions necessary for fusion. But here's the tricky part: plasma is chaotic and volatile. To keep it stable, fusion rockets use incredibly strong magnetic fields generated by superconducting magnets. These magnetic fields act like invisible walls, holding the plasma in place and directing the thrust out of the rocket's nozzle to create propulsion. It's like trying to trap lightning in a bottle while also using that lightning to push you across the universe. Now, if fusion rockets have so much potential, why aren't we using them already? Well, the technical challenges are enormous. First, you need a tremendous amount of electricity to power the lasers and magnets. Second, acquiring and storing the right fuel, especially tritium or helium-3, isn't exactly easy or cheap. And finally, the entire system needs to be light and compact enough to fit on a spacecraft, while also being reliable enough to work over years of continuous use. Here's an interesting twist, though. Building a fusion rocket is actually easier than building a fusion power plant on Earth. Why? Because a rocket doesn't need to be perfectly efficient. It just needs to produce thrust. On Earth, fusion reactors are trying to create a net positive energy output, more energy out than what you put in. But a fusion rocket can afford to be inefficient as long as it produces enough thrust to accelerate the spacecraft. So, what's the timeline for all of this? Optimistically, we might see working prototypes of fusion rockets within the next 20 to 30 years. The technology is progressing, but slowly. We're still learning how to better contain plasma, produce stable fusion reactions, and convert that energy into usable thrust. But with advancements in superconductors, magnetic confinement, and laser ignition, we're inching closer every year. The bottom line is this: Starship is revolutionary, but it's built on the same basic principles of propulsion we've been using since the dawn of rocketry. If we truly want to become a multi-planetary species, We need to break free from those limitations. Fusion rockets could be the key. They offer the promise of fast, efficient, and powerful space travel that could open up the entire solar system. Not just Mars, the race is on. And the finish line is the stars. If you enjoyed this video, don't forget to smash that like button. It really helps the channel grow. I'd love to have you back for the next one. Until then, stay awesome.